Hey folks, QCon New York is returning to Brooklyn this June 13th to 15th. Learn from over 80 senior software leaders at early adopter companies as they share their firsthand experiences implementing emerging trends and best practices. From practical techniques to pitfalls to avoid, you'll gain valuable insights to help you make better decisions and ensure you adopt the right organizational patterns and practices. Whether you're a senior software developer, an architect, or team lead, QCon New York features over 75 technical talks across 15 tracks, covering MLOps, software architectures, resilient security, staff plus engineering, and more to help you level up on what's next. Learn more at QConNewYork.com. We hope to see you there.
Welcome everyone to the InfoQ podcast. My name is Roland Meertens, your host for today, and I will be interviewing Tomáš Neubauer. He is the CTO and founder of Quix. We are talking to each other in person at the QCon London Conference, where he gave the presentation Simplifying Real-Time ML Pipelines with Quix Streams, an open source Python library for ML engineers. Make sure to watch his presentation, as it delivers tremendous insights into real-time ML pipelines and how to get started with Quix Streams yourself. During today's interview, we will dive deeper into the topic of real-time ML. I hope you enjoy it, and I hope you can learn something from it. Tomáš, welcome to the InfoQ podcast.
Thank you for having me.
You're giving your talk tomorrow here at QCon London. Can you maybe give a short summary of your talk?
Sure, yeah. So I'm talking about open source library Quix Streams. It's a Python stream processing library for data-intensive workloads on top of Kafka. And I'm talking about how to use this library in projects that involves real-time machine learning. And I'll talk about the landscape, different architecture designs to solve this problem, pros and cons of each. And then I kind of put this against a real use case, which I, at the end of the presentation, develop on stage from scratch. And in this case, it's detecting a cyclist crash. So imagine a fitness app running on your handlebars and you crashed and you want to inform your relatives or emergency services.
So then you are programming this demo live on stage. Which programming language are you using for this?
Yes, I'm using the open source library Quix Streams, so I'm using Python. And yeah, I basically start with having just the data from the app, telemetry data like G-force sensor, GPS location, speed, etc. And I use machine learning model that has been trained on history data to detect that the cyclist crashed.
And what kind of machine learning model is this?
It's a TensorFlow model, and we basically train it before, so that's not done on the stage. And we label data correctly and train it in Google Colab. And I'm gonna talk about how to get that model from that Colab to production.
Yeah, and so if you're talking about real-time machine learning, what do you mean with real-time? How fast is real-time? When can you really say this is real-time ML?
Well, real-time in this case would be 5 times per second. We will receive telemetry data points from the cyclist. So all of these parameters that I mentioned will be 5 times per second streamed to the cloud. And we will, with, I would say, 50 milliseconds delay, inform either the services or consuming application that there was a crash. There's no 1 hour, 1 day, 1 minute delay.
Yeah, okay, so you get this data from your smart device and you're cutting this up into chunks, which you're then sending to your API or to your application?
So we streaming this data directly through the pipeline without batching anything. So basically it's coming piece by piece and we are not waiting for anything either. So every 200 milliseconds we do this detection and either say this is not a crash or this is a crash. And in the end of the presentation, I would have a simple front-end application with a map and alert. Because obviously I'm not gonna crash bike on the stage. I'm gonna have a similar model that would detect shaking with the phone. And I'm gonna show everyone that the shake is detected.
And where does this come from? How did you get started with this?
The roots of this idea for this open source library is coming from my previous job, where I was working in McLaren and I was leading a team that was connecting F1 cars to the cloud and therefore to the factory. So people don't have to travel every second weekend around the world to build real-time decision insights. What I mean by that is basically deciding in a split second that the car needs different tires, different settings for the wing, etc. And it was a challenging use case, lots of data, around 30 million numbers per minute from each car. And so we couldn't use any sort of database technology that I'm going to talk about in a presentation. And we had to adopt streaming technology. But the biggest problem we faced actually was to get this technology to the hands of our functional team, which were made of mechanical engineers, ML engineers, data scientists. They all use Python and really struggled to use this new tech that we give them.
And how should I see this? So you have this car going over circuits, generating a lot of data. This sends it back to some kind of like ground station, and then do you have humans making decisions real time, or is this also ML models which are making decisions?
The way how it works is that in the car there are sensors that are collecting data. Some of them are even more than kilohertz, or more than 1,000 numbers per second. That is streamed over the radio to the garage, where there's a direct connection to the cloud. And then through the cloud infrastructure, it's being consumed in a factory where people during the week building new models, and then in a race day, there's plenty of screens in the garage where there are dashboards and different waveforms, which basically visualizing the result of these models. So the people in the garage can immediately decide that car needs something else.
And so this is all part of the race strategy where people need to make decisions in split seconds and just need the data to be available and the models to run in split seconds.
Yeah, exactly. And basically, during my time in McLaren, we took that know-how from racing and actually applied it outside. So at the end, we end up doing the same thing for a high-speed railway in Singapore, where basically we were using a machine learning to detect a brake and suspension deterioration based on the historic data. So there are certain vibration signatures that will lead to a deterioration of the object.
And you were talking about like different programming languages, like either Java or Python. How does this integrate with what you're working on?
Basically, the whole streaming world is traditionally Java-based. Most of the brokers are built in Java or Scala. And as a result, most of the tools around it and most of the libraries and frameworks are built in Java. Although there are some ports and some libraries that let you use these libraries from Python, although there are just a few of them, it's quite painful because this connection doesn't really work well. And therefore, it's quite difficult for Python people, especially people from data teams, to leverage this stack. And as a result, most of the projects really doesn't work that way. And most of the people work in Jupyter notebooks in silos, and then software engineering taking these models into production.
Yeah, so what do you do to improve this?
What I believe is that unless data team work directly on product, it's never going to work really well because people don't see the result of their work immediately and they are dependent on other teams. And every time that one team is dependent on another, it just kills innovation and efficiency. So the idea of this is that a data team directly contribute to a product and can test and develop straight away. So the code doesn't run in Jupyter Notebook or stays there, but it actually goes to real-time pipelines. And so people can immediately see the result of their work on a physical thing.
And you mentioned that there's different ways people can orchestrate something like this, like there's different ML architectures you could use or you could use for such an approach. Which ones are there?
Yeah, so there's many options to choose from all different dimensions that you look at the architecture of building such a system. But one of them is obviously if you're going to go for batch or streaming. So are you going to use technology like a Spark and react to data in batches? Or you need a real-time system where you need to use something like Kafka or Pulsar or other streaming technologies. And the second thing is how you're actually going to use your ML models. So you can deploy them behind the API, or you can actually embed them to a streaming transformation. And discuss both cons and pros of each solution.
And what do you then mean with a streaming transformation?
This is a fundamental major concept of what I'm going to talk about, which is a pub and sub service. So basically, we're going to subscribe in our model to a topic where we're going to get input data from the phone, and we're going to output the results. Therefore, is there a crash or no? And this is the major architectural cornerstone of this approach.
Okay. And you mentioned, for example, Kafka, and you mentioned some other tools. How does your work then relate to this?
Yeah, well, what we found out is that Kafka, although it's powerful, it's quite difficult to use. So we have built the level of abstraction on top of it. Then we found that that's not enough actually, because streaming on itself introduces complexities and different approaches to common problems. I have a nice example of that tomorrow. So we are building abstraction on top of streaming concept as well, which means that you would operate and you would develop your code in Python as it would be in Jupyter Notebook. So what you are used to when you're working with the static data would apply to building a streaming transformation.
And how do you do this? So can people test this with a pre-recorded stream, which they then replay? And can you still use a Jupyter Notebook? Or do you, as a machine learning or like as a data scientist, do you then lose part of your tooling? Or
So the Quix Streams is an open source library that you can just download from pip and use and connect to your broker. If you don't have a broker, you can set it up. It's open source software as well. If you don't want to, you can use our managed broker as well. It doesn't matter, works same. And then we have some open source simulators of data that you can use if you don't have your own. So for example, we have F1 simulator, which will give you high resolution data. So that's quite cool. You can also, for example, subscribe to Reddit and get messages on Reddit. Or you can use the app I'm going to show you tomorrow. It's also open source. So you can install it from App Store, or possibly you can even clone it and change it to suit your need and deploy by yourself.
so then Quix handles both text messages, but also audio, or what kind of data do you handle?
Yeah, so we handle time series data, which involves a numerical and string values. Then we handle binary data, which is audio and video and geospatial, and etc., where we kind of allow developers to just attach this under the column. And then we have a metadata, so you don't have to repeat, for example, that this bike has a firmware 1.5. You just send it once, and the stateful pipeline will persist that information. And then at the end, you also can send events. So, for example, crash is a good example of event which doesn't have any continuous information.
Yeah, okay, so can you also connect these pipelines such that one pipeline, for example, gets all the information from your sensor and then sends events to another pipeline? Is this something which is chainable?
Yes, so the whole idea of building systems with this approach is to building pipelines. So each node in your architecture is a container that connects to one or more input topics and output results to one or more output topics. You create like a pipeline that has multiple branches. Sometimes they join back together, sometimes they end. And when they end, they usually either go to database or back to the product. And same is with the start. Start could be from your product or could be CDC from database. So you have multiple sources, multiple destinations, and in the middle you have one or more transformations.
And is there some kind of limit to the amount of inputs or the amount of consumers you have for a pipeline?
There isn't really a limit to number of transformations or sources. One thing is that Kafka is designed to be one-to-one or one to a small number of consumers and producers. So if you have a use case like we're going to do today with the phones, where you can possibly have thousands or millions users, you need to put some sort of gateway between your devices and Kafka, which we will do. And in our case, it would be a WebSocket gateway, collecting data and then funneling it to topic.
Yeah, okay, so do you still have some kind of queue in between, or?
So there's really any queue in between, but there's a queue obviously in Kafka. So as the data flowing to the gateway, they are being put to the queue in topic, and then the services listening to it will just collect, consume, and process this data from that queue.
You already have some consumers who are using this in some creative or interesting ways. What's the most interesting use cases you've seen?
Yeah, so one really cool use case is from healthcare, where there's a sensors on your lungs and listening to your breathing and then being sent to cloud, and machine learning is used to detect different illnesses that you have, and that's all going through the companion app. So it's quite similar to what we're going to do here. Then second quite interesting use case is in the public transport, Wi-Fi sensors detecting the occupation of the underground stations and automatically closing, opening doors and sending people to a less occupied parts of the stations.
Oh, interesting. So then you have some kind of signal which tells you how many people there are in certain parts of the station?
Yes, correct. So you have the routers all around the station, and then in real time you know that in the north part of the station there's more people than the south, and therefore it will be better if people come from the south. And you can do this in a split second.
Oh, interesting. And then in terms of the implementation, if we, for example, want to have some machine learning model act on it, are there specific limitations or specific frameworks you have to use?
So basically the beauty of this approach is, and I think that's why it's so suited to machine learning, is that it's just a Python at the end where all the magic happening. So you read data from Kafka into Python, And then in that code, you are free to do whatever you want. So that could be using any pip package out there. You can use the library like OpenCV for image processing. And really anything that is possible in Python is possible with this approach. And then you just output it again with the Python interface. So there's no black box operation, there's no domain-specific language like you would find in Flink.
So do I basically just say, whenever you have a new piece of data, call this Python function with these arguments?
Correct. And even more than Python functions, you can build Python classes with all the structure that you are using in Python. You can also try it in Jupyter Notebook. So the library will work in a cell in Jupyter Notebook. So again, there's basically a freedom of deployment, and running this code anywhere is just a Python.
So if people are listening and they're beginners in real-time machine learning, how would you get started? What would you recommend to people?
Yeah, well, first of all, what I'm doing here today, it's available as a tutorial. All the code is open source, so you can basically try it by yourself. There are other tutorials that we have published that go into different use cases and going step by step from literally installing Python, installing Kafka, things like that to get this going from the start. So I recommend to people to go to docs that we have for the library. There are tutorials and there are some concepts described, like what is the detail of this. So yeah, that would be the best place to start.
Are there specific concepts which are difficult to grasp, or is it relatively straightforward?
So what is really complicated is a stateful processing that we're trying to solve and abstract from. But if you are interested to learn more about stateful processing, we have it in the docs explained. That's a very interesting concept, and it will open the intricacy of the stream processing. But I think the goal of the library really is to make it simpler. Obviously, it's a journey, but I'm confident that we already have done a great job in making it a bit easier than it was.
Yeah, thank you very much. Thank you for joining the podcast, and good luck with your talk tomorrow, and hopefully people can watch the recording online.
Yeah, thank you for having me.